Assalamu alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about arrays of structures within functions. Now, as a precursor, lecture 3 talked about structures, lecture 4 talked about arrays, and lecture 5 talked about functions. So this lecture, we're going to use the three things we learned in the three lectures and combine them together in one cohesive format. Now, just as a reminder, structures are in fact like user-defined data types, and arrays allows one to have multiple elements of the same type. Also, functions help you break down big tasks into manageable sub-problems. Now, this is an example where you have integer a, b, c, d all the way till z. So there are about 26 variables in there, all of the same data type integer. We can see that this is really hard. Number one, it's there you have to actually type in all the characters of the English language. But secondly, you have to remember which variable is used for which. You probably have to do the same here, but here this component is much more simpler. So by using arrays, you have this one variable by the name of alphabets, which acts as an array of the data type integer, where each of the element within this alphabets array, all 26 elements are of the same data type. So the general formulation is data type, name, and within square brackets the size. So all the individual components of the array all have the same data type. Consider now this example of a structure, and I'm using the word element. You can really use any name that you want. So the structure actually allows you to put multiple data types, multiple variables of different data types within the same object per se. Now the element here has two variables within it. One of them is the name of the type string. So whenever you use the string, you have to include string, and value of the type integer. In fact, you can have structures within structures within structures. That's also allowed. So using the same formulation that we saw here, where you have the data type, the name of the variable, and the number of elements, or the size of the array, as mentioned here, you're going to use the same thing here. Remember, structures are user-defined data types, so element now can be used as a data type, so hence the data type comes first, then the name of the variable. In this case it's students, right? Every student has a name and some marks which is going to be allocated to the value, and 80, right? So now students is an array of structures, right? And how many, the size is 80. That could be the size of, let's say, a particular session attending this class. Now, hence really, if you really looked at, so this is our structure element, and we've declared one variable a. So in order to initialize different components within a, we are going to use the dot operator. So a dot, now I can access all these individual components. So a dot name has been assigned Bilal Wajid, and a dot value has been assigned 90. Now, because previously we just declared an array of structures, which is element, students, and 80, we can actually use pretty much the same format that we've seen here, right? Element, students, 80. So now I'm just saying students 1 dot name and students 1 dot value. So it really, the dot operator works the same way as any normal structure, without even an array. So but this index is in fact important, because every index out of the 80 indexes here holds a complete structure altogether. So student 0 is one structure element, student 1 is another structure element, student 2 is another structure element, and kind of like you can think of it this way, that this structure students, array of students, actually allows you to hold the, let's say, the marks of 80 students, their name and their corresponding marks of, let's say, the course data structures. Now, as a precursor to the program, now because now we've talked about arrays and structures, and now we have to integrate functions within it and how we can pass on these array of structures for initialization or for any other purpose. So as a precursor to the program, every program should have these comments. They're actually very useful. It's worthwhile to mention the author, the last time updated, and some description of what really the program is all about. Then comes our all important packages, include IOStream, and using namespace standards allows us to use the cin and cout commands. And finally include string is needed whenever you use the string data type. So because we're using that for the name, we do have to include that. Now there now comes all the global variables, all the definitions, in this case the structured declaration that actually comes here. So you have comments, our import statements, and any global variables or structure definitions that need to become, they need to come. Now the main function of this program actually has one declaration, which is our students. So this is an array of students of the type element, and the size of the array is 5. So we're really talking about just 5 students. And now I'm calling out this function called input marks, where I'm giving it, where I'm passing as an argument the array of structures, and I'm also passing the size of the array. So this is a very important principle and a concept to worthwhile to remember. Whenever you pass an array to a function, always remember to pass the size of the array. It will really help you. Similarly, it's followed by another function called print statistics, which actually maybe uses this array of structures to calculate like what is the highest score, lowest score, or average score. Here we initialize the array, and here we use it to make some calculations. So let's just first look at the first function, input marks. So the first function, input marks, has this, we're passing, remember, this is just a part of the main function shown for instant reference. So we were really passing the size of the array and the array of structures. So whenever you pass this array of structures, you have to really tell, okay, what is the array? Here I'm using a different word, children. I'm using a different word deliberately, really, because this is a because I mean, it helps. And you would see sometimes I felt students somewhat confused when they overly use the same variable name. So here students is being reflected as children. It is of the type element because it is a structure, and notice what I'm doing here. The square brackets tell us that this is an array. The other thing worthwhile noticing is that this square bracket is in fact empty. Now what we really did here is that it's kind of like not empty in some sense, because we are already giving it the size of the array in this case, right? The size of the array was 5, and we were actually passing it as an argument of the array. This here is, you could say, an implicit definition of how about the size of the array. So the function as return type void, it means it's not really returning anything. As you can see here, the last statement is just return semicolon. It's not really returning our 0 or 1 or 2 or anything really. So the input marks doesn't really return. What it does, it initializes an array. Now the arrays behave differently. In fact, arrays act like global variables. So whenever you pass an array onto a function, any changes made to that function, any changes made to that array will remain with the array when the function returns. So it doesn't act like a local variable, it acts like a global variable. And when we are studying pointers, we can actually tell you how it's actually done and why do arrays behave somewhat differently, right? Although they are not really, if you look at this function, they are not really declared as a global variable. The only global like definition is that of an element. Otherwise I would have mentioned element student, let's say 5, but I didn't do that. I actually declared the array of structure part of the main function. But we see here that it actually is being passed, and whatever changes are made here are reflected here. So they do act somewhat like global variables. Now, what we are doing here is we're really declaring a loop. The loop starts from 0, which is the first location, and ends at n-1, which is the last location, right? Remember, arrays start from 0 up until n-1. And really what we are doing is for every variable, let children I, we're just assigning it a name and a value. And a value could be marks, let's say, because I've written here input names and marks of students. Okay, so by the end of this loop, all the components or all the elements of this children array are actually initialized. So let's look at the other one, which is the print statistics. Remember, this is being mentioned here for instant reference. In the main function, we actually declared an array of structure student of the type element having 5. So we are talking about 5 students. In the second function, the one that we just saw previously, we actually input their marks, the name and the marks. And the third one, we are just reusing it again and calculating some statistics. So what statistics are we really calculating here? Again, notice the print statistic function is of the type void. In other words, nothing is being returned here. This is the name of the function, and then the size of the array n, and what is the array of all about. The array is actually of the type element, which is a structure. So it is an array of structures. So the print statistic really does is calculate the highest marks, the lowest marks, and average. Now these are the initializations. Initially, I'm going to assign highest to be the 0th value, the lowest to be 0th value, and average to be 0. The average, in fact, is the running sum. So here again, I start the loop. It starts from the 0th element all the way till n-1, and whenever I find a value larger than the highest value, I update the highest value. And whenever I find a value lower than the lowest value, I update the lowest value. As far as the average is concerned, it's just the running sum. But we know the average is not the running sum. So we divide this running sum, or the total of all the marks, divided by n. That is the number of students or the number of children in class. Now we have the average. And lastly, we have a bunch of cout statements which prints the lowest, the average, and the highest, because remember, the name of the function is print statistics. So we're actually printing those values right here. And the function is void, so we don't really need to return anything. If we see the main function or the whole program, we have our beloved comments at the beginning, our include statements, our definition of structure, and then finally the function input marks we just saw 2 slides ago, and the function print statistics we just saw in the last lecture. So this is the main function. So let's see how this really behaves. Okay, we're going back to our beloved CPP shell. This is our function, right? These are our comments, these are our include statements, our structure declaration, our function void marks, and then our function print statistics. And finally we have the main function, right? Because the main function is using the structure element, that should be declared first and defined first. Because the main function is using two functions, both the functions should be declared and defined prior to the main function. So let's see what happens when we run this. It's compiling. So let's do something a little different right now, because cpp.shell is not really working. So I'm present in this folder where my current lectures are actually the programs for my lectures are given, and I'm using the Ubuntu operating system, and similarly the same rule applies for Windows. So right now, if I just look at the CPP programs, I've opened the terminal. It shows here there are two programs, this lecture 5.cpp and lecture 6.cpp. And I guess in Windows you're going to write dir, which is not dir, something like this. And then what you're going to do in order to compile this, you're going to write g++ -o. So g++ is our compiler, -o for the output. So for the output, I want a program lecture 6. I want the executable to be named just lecture 6, and the input is going to be lecture 6 dot cpp. I guess it's worthwhile to mention that .cpp is the extension of C++ programs. I press enter, and lo and behold, you see that this suddenly appeared. So this is our executable file. In Windows you would actually write it as lecture6.exe. Ubuntu doesn't require an extension, so you're just going to write dot oblique and then write lecture 6 and press enter. So here it says input names and marks of students. I'm going to write Bilal as the first name. Marks could be, let's say, 85, and then I'm going to say, let's say, Zishan as the second name. Marks could be like 90, and then the third name is, let's say, Imran, and the marks are, let's say, 95. They keep, seemingly everybody is better than me. And then let's say Danish, who has, you know, full marks, and then there is just me again, Bilal 2, who this time gets even less marks. He went for rechecking his exam and he ended up with less marks. And when I press enter, because you know, remember we just had 5 students, when I press enter, the statistics are calculated and shown. The lowest is 80. We can see here the lowest is in fact 80. The average is 90, because I mean there are 2 marks greater than 90, which is 95 and 100, and 2 less than, and the highest is 100. Okay, so it's really worthwhile if you really open this. This is just any editor that you can use any editor you want. When you usually write, when you save it with an extension CPP, you would see the editor will automatically put a lot of these things in color. And you've noticed a lot of my lectures, I'm actually using colors. These colors are there for a reason, so that you know, whenever you write the program, you see that a lot of these things are actually colored at the end of the day. So you can use any editor you want, and it's really worthwhile trying right now to see if this works in your system. Up until next time, thank you very much. Remember, you learn programming by doing it, not just by listening to these lectures. They're only a helping tool. Thank you very much. Bye bye.